right, welcome back. On this week's episode of Bone Apple Tea, we talk about mechanical engineering and Randall.
That's
and
right.
His experience, basically the last week's episode, but his version.
Right.
And through high school, college, grad school, and then work, how they relate, kind of takeaways from each thing, and then some advice for people that are trying to go into mechanical engineering or biomedical engineering, perhaps.
Yeah.
At the end there. And
song of the week is Apple Acoustic by Good Hustle.
Good old us.
Yes. And yeah, that's pretty much it.
Damn it. I hate when that happens.
All right.
Enjoy. But anyways, yeah, enjoy. Mannequin design right now. This is stupid shit. This is why we have podcasts.
Yeah.
Let's talk about stupid shit all the time. All right. This is a special one.
Special.
Not as special as the last one, because the last one was about me and this one's about you. So.
I know. It's not as special, but some could say even more special.
Maybe.
If you were to twist it around a little bit.
I don't know, your mom or something. Even then, I think she would probably say mine was a little more special. But, we don't have to get into that right now.
Good. Definitely the last one's more intelligent.
But, I have a few questions for you.
Oh, yeah. You do. You think you could just come in here and ask me questions? What do you want to know about?
Bandcamp 2010. What happened?
Dude.
Because I'm hearing some mixed things.
What happened at Bandcamp stays at Bandcamp, dude.
I just, I didn't know you were a wind instrument guy, but
I played the clarinet in high school. I did you? I played the...
All right, Squidward. Anyways, so no, what I actually wanted to ask you was, obviously we were doing the whole kind of high school transition into college, transition into
grad
job
school.
life.
Yeah. Yep.
Sorry, I'm just stupid thoughts in my head.
Yeah.
Anyways, into like college, grad life, and then work, and kind of how it went for engineers.
Right.
I did mine EE. This is kind of the ME.
Yeah, ME / more like CE, civil engineering.
Yeah, like a kind of a combo-ish thing because you're doing now
civil engineering is more what I do. Actually.
Yeah, some structural analysis and that kind of stuff.
Right.
So, really, all right. So in high school. What was the deal? I know, obviously, you thought, I think, BME at first.
Well, yeah. What was crazy is ever since I was a kid, I always wanted to be what I called back then, little kid, was a scientist. My mom had gotten these books, DNA is Here to Stay. You can look it up. It's like a kid's picture book, and it's all about DNA. And I loved it. And she would read it to me. And for whatever reason, the books must have been written well because I actually paid attention to them. And I was in second and third grade. Yeah. And I knew all about it. And I remember seeing the word deoxyribonucleic acid and being like, what? That's a word? And, but anyhow, and so by the time I got into high school, I was like, I really think I should be an engineer. I was really good at math. And I was like, well, math and science is pretty much engineering. So that would be pretty cool. And I think for a while, I thought I wanted to be a mechanical engineer just because I thought it meant you got to build stuff. That was my initial thought.
What was the, because I know you went to a small school, so I know you guys didn't have a crazy amount of resources and stuff.
Yeah.
So what was the highest level of courses you could take at your school? Was there a limit where?
Yeah, this is actually kind of a funny story. So we tapped out after Calc 1. They had some other they had AP Bio. I was the first class that took AP Bio.
Was it a big class? Well,
no, it was 5 people, maybe 5 or 6 people.
See, it's almost better though, because it kind of means in the sense that you're getting more attention from a teacher,
right?
But
Mr. Kopek was the best too. He was just such a great guy. I loved Mr. Kopek. He was actually in that class is the reason I ended up going into BME instead of ME, because I had a conversation with him and I was like, oh, I think I want to be a mechanical engineer. This is my senior year. He's like, oh, well, you're really into this whole biology thing. You might want to give a look at biomedical engineering. And I was like, biomedical engineering?
Yeah, what is that?
Right. And I did very little research and was like, that sounds like what I want to do. So that was pretty much that. But the funnier part was you asked how many resources and what the limit was that our school went to.
Real quick, was that the guy you sent the letter to? Did you end up, how we had to write a letter to our teachers?
Yes, he was.
Okay.
Yep, I wrote it to him. Yeah, in Engineering 1000.
Yeah.
Yeah, I ended up writing him a letter. Yeah. Who was yours to?
It was my AP Chem teacher, Mr. Wieder. I didn't know who to send it to, and I guess I always shot with him after class, but it was just kind of funny.
Yeah,
dude.
Yeah,
thanks.
we were really close. I would say as far as student teacher closeness. I would see him every day and we'd talk, and he was as much as he was Mr. Kopek, as much as he was a science teacher, he was positive, like life fulfillment teacher too. Like every day he'd have a different quote on the board about, positive thinking or reinforcing life goals.
Sounds like he liked his job.
Yeah, he definitely did. He used to wear fun socks. He was the first teacher I ever saw that wore like creative socks. They had like donuts or puppies or something on it. He was just that kind of guy. But so our school capped out at Calc 1, and I had finished Calc 1 my junior year of high school. And I was like, can I do Calc 2? And so they set up a program for me to do Calc BC, but it was just me and the teacher the whole year.
That's so strange.
It was just me and the teacher the whole year.
Oh, so you took BC Calc.
I took Calc BC, yep. Which is like the second version of Calc.
Yeah.
Because there's Calc AB and then BC.
That's like higher than,
Yeah, it's essentially Calc 2.
Yeah.
And then is that Kevin? Is he meowing to get in right now?
Yeah,
should we open the door to let him in?
Yeah,
here. Hold on, we'll take a pause on that.
We'll get a cat on the podcast. Podcat. Where'd he go? We got to get the podcat on. Just grab him. Screw it. Nah, he likes to bitch until you actually let him in. And then he just
I was
runs
hoping
away.
we could get Kevin on the podcast. Maybe we'll have to get him in on a fun episode. Anyhow, so it was just me and the teacher the whole year. And so like, it's just weird because like, when you're in high school, I'm sure a lot of people out there are like, what the hell? Like I went to a class, like I was just talking to someone today and they were like, yeah, my class was pretty small. It was like 127 kids in my class. And mine was a graduating class of 36. And so like,
yeah, that's crazy.
It's so small. I mean, it's like, it doesn't even make sense how small that school is. And so having me and just the teacher all year, you can imagine that like, it's almost like being in a relationship. You walk in and there's like, you got to deal with your shit, because you can't hide. There's no like, oh, I forgot my homework, because you're the only one forgetting your homework.
Yeah, exactly.
There's like, if you're underperforming in the test, there is no class average. It's just you average.
Yeah. So that's true. That's crazy.
It was very strange. It's funny, actually. I'll bring this up. It ended in kind of a ball of fire, unfortunately. Not like too bad, but like, happened? Well, so I had worked my ass off the whole year, and how AP classes work is that when you get to May, you take the exam. And then there's like the last month where there's not much to do in the class because the class has been over with, you've taken the test, everything's good. And so I thought like, it's my senior year, I had busted my ass all year long. I thought the teacher was going to be like, okay, like she did with all the other classes, which is give them like bullshit assignments, like make a math poster. And that's your assignment, A
math poster?
Yeah, like because you had gone through the whole year and you took the big exam, really. And then there's nothing more to teach, And plus I was a senior, so I was like, hey, like, I'm a senior graduating, And instead she started giving me more material, and I was like, I don't want to do this. Like, I already took my test, and like everyone else is making posters. How come I have to like learn new stuff?
Yeah.
And we pretty much got into a bit of because remember, it's just me and her. So we got into a bit of a disagreement, and I ended up just taking the rest of my year in like a study hall.
Really?
Yeah.
Oh my God.
Yeah, it didn't work out well because I like purposely didn't study for a test that she gave me as like a way to be like flippant, and she ended up marking it against me. And it was the only A I didn't get on my report card.
That's so stupid though. Like, why does she care at that point? I mean, you already finished the contents of the class. What was like I
don't know. It was so strange. I was like, what's going on? Like, why? Like, we've had such a great relationship. Why are we trying to sour this right now?
Yeah, that's kind of dumb.
Someone could view that as me being a bit of a bitch. So that's up to you.
You're a high school kid, so I'm sure.
Whatever. But
more.
But yeah, so that was kind of like, how I had approached high school. I had ended up being valedictorian. Now, being valedictorian of a class of 36, say what you will, but that pretty much secured me into going into UConn because they had that whole presidential.
It was like free, right?
It was free to. This is so funny how they do this. It's free or not free tuition, but tuition covered for the year that you go in. So if you go in and tuition costs $5,000 a semester, I don't know how much it actually is. If it costs whatever it does, if the price ever goes up, you don't get that extra money.
So you pay the difference between the cost of when you entered and
when you leave. Exactly. So still a great deal. And that was pretty much the whole reason I ended up going to UConn. Now the thing was, before I go into college, is there anything else about high school you want to know?
No, I mean, like, I guess, did you So you already knew you kind of wanted to go into engineering when you were in high school?
I was very different from just about every kid I knew, because every other kid I knew did not know what they wanted to do in college and was more of like I'll think of something.
Yeah.
And I knew I'm going into engineering, and the only thing that changed was biomedical versus mechanical.
So then expectation wise, when you actually went to college, was it what you thought it was going to be? Or
so this is the thing. I was going in as a valedictorian, and I had a big head, and I really thought that, I was, maybe someone special, or that I had figured school out.
Yeah,
you know what I mean? I felt like I was at the top of the food chain, and school was school, and whatever school threw at me, I was going to be able to do. Well, I got to college and it fucking turns out not so much.
Yeah.
It's like, oh, wow. There are some legitimately ridiculously smart people here.
Yeah.
And now I'm just a fish in a huge ocean, no longer a fish in a pond, you know what I mean? Or whatever, big fish in a small pond.
Yeah.
Whatever the analogy is there, metaphor. When I got to college, it was a very big surprise, because now instead of just I used to study, but now I'd have to put that real extra effort in to actually obtain a really good grade.
Yeah.
Good grades weren't just
volume of work.
Right. The sheer volume of work, and then the expectations were much higher than they were in high school.
Mm-hmm.
And so I think I was definitely really surprised. I actually got my GPA my first semester was a 2.8.
Oh shit.
Yeah, it was pretty bad. I ended up getting a C in the MATLAB programming class.
Oh yeah,
I hated that class.
Yeah, that's funny. I hated that class too. So I was like, why the hell am I in this class?
Dude, I hated that class so much. I tried studying for the final. There must have been a huge curve on the exam, by the way, because I tried studying for it, and I checked my, when you get your results back or whatever, for this particular final exam, you got them back really fast. I got 3 questions out of 21 correct. On a final.
That's
final, dude. And the only thing that saved me was that my homework grades were really high.
Mm-hmm.
And so because of that, the final, I think, was only worth 15% or 20%.
Oh, they did that adjusted based on whether or not your grade would be worse if this weighting was.
I think he curved the shit out of my grade, dude. Because I really I think even with that, I think I should have gotten a D or something. I think he ended up curving a ton of people. It was Jeff.
Because they did
Jeff?
I didn't have him. I had CC.
Yeah, I liked him as a teacher, but I heard some weird stuff happen to him after college. But yeah, I don't really know exactly, so I'm not going to say. But yeah, it was just way different coming into college. I think the expectations of, I got school versus I got schooled. You know what I mean? Not to sound cheesy and corny. I think Andy would probably hit me in the face. Yeah, I think Andy would probably slap me in the face for that one. But that's pretty much what it was coming into college. I was just surprised, even freshman year, how much I had to give more effort to.
It's you don't really realize, and then especially after the first semester, you're like, oh shit, that's just a lot more homework and a lot more. I was always kind of the opposite, where I would just not do my homework and then just show up and take the exams and do well in the exams.
Yeah. Well, you're like a prodigy child in that sense. You wouldn't go to class and you just read the book and teach it to yourself. That was you.
Yeah, man, books work. But yeah, so all right, so I guess freshman year is a lot of basic. Chem 1, physics 1, blah, 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 whatever. So, did you have any, intro level classes that stuck out to you? And, any key concepts where you were like, oh, this is super important?
Right. I would say the basics of calculus 1 and 2 end up transitioning to the rest of engineering everywhere. Mm-hmm. So because everything at some point in time, at least with mechanical engineering especially, transitions to either a derivative or an integral.
Yeah.
You're going to be deriving an equation, probably finding the area under the curve, mm-hmm. and then saying, now the area under the curve in calculus means just the number. But the area under the curve in, mechanics of materials could be, some property value, or it could be some summation that you mm-hmm. need to find out. And so these equations end up helping you out. So I would say probably Calc 1 and Calc 2, and Calc 3 later on. But I would say Calc 3 is more I guess we all took it sophomore year, right?
Calc 3.
I think I took it sophomore year. No, I took Calc
junior year, I think.
Dude, I'm pretty sure I took Calc 3 freshman year. Because
no, you're right. Sorry, I took it first semester sophomore year. You must have taken a second semester.
Yeah, because I ended up and this is smart too, guys. If anyone's listening, trying to think about going into engineering, if you take a calculus level course in high school, you can take it again in college, which is what I did. I took Calc 2 again in my first semester because I wanted my first semester to feel easier as I adjusted. And I'm glad I did that because I quickly realized that everything was a lot harder, not even just in terms of content, but in focus. Because when you're living at home and all you have to do is go home and do your studying, it's a lot easier than when you go back to your dorm, you put your bag down, you only had one class or two classes that day, and you don't feel like doing anything. Yeah. And all of a sudden you got these new friends hitting you up. And you're like, yo, we're going to go out. We're going to hang out on the quad. We're going to play basketball. We're going to do this, whatever, workout, whatever it is. And or we're going to go to a soccer game. We're going to go to a football game. Like, you're like not thinking about homework.
Yeah,
you know?
For sure. I mean, it's completely different. Like, I don't know. It was kind of crazy going in because you're right. I mean, you're like kind of trying to hold yourself accountable. It's like your parents aren't going to be like, hey, did you do your homework? It's
right.
You can fuck off and do whatever you want.
Right. And you can be like, I'll get it done at some point, But yeah, I would say as far as intro level courses, just to circle back around, I'd say Calc 1, Calc 2 probably be the biggest ones that ended up playing a huge favor later on.
I was going to say, like, I think for like mechanical side of things, I mean, the only, or one of, I guess I should say, because we took more later, but like statics, the whole like some of the forces, the X and the Y and the sum of the moments. I'm like, that's like everything in mechanics or like, I guess, static analysis. Like whenever I think of, what are the forces on this, beam, blah, blah, blah. I'm like, oh yeah, statics, sum them up.
Yeah, you're right. So, and I forgot because statics was like a sophomore level class, wasn't it?
Yeah.
So that's okay. So that's, we'll call that more intro level. Yeah, I'd say statics was probably, for me personally, the most helpful class when it came to understanding anything mechanical. Now, if you don't know what statics is pretty much analyzing bodies, and bodies could be a beam, it could be a bridge, it could be whatever. And you put forces on it and you analyze what happens to it or what pressures it feels or stresses and strains it feels after that force is applied. And so you can use mathematical equations to solve for those stresses at different points of the beam. And so the point that drives it home as far as it being important is it gives you an introduction to understanding how stress develops within materials, within random bodies that have forces on them.
So do you have any like projects that stick out to you that you got involved in that were, I guess, like a memorable moment in class type of thing?
Right. Well, because
we did biomechanics.
Yeah, I should also talk about the biomedical aspect too, because I did go in as BME. My focus was biomechanics, so I took more mechanical material based classes, but projects, man, some of the big ones really came out of all our BME ones. So all of our BME classes. So one of the first ones, and I liked it a lot, and I think we talked about on your episode, was making the equalizer. Yeah. That was a ton of fun. That was like one of those things where it was a summer, we were doing it over the summer, and it was, warm or whatever, but it's just a good time. And then we made that EQ, and I was like, wow, like I use a digital version of this very thing. Yeah,
it's kind of funny because I didn't really realize that you were into music and stuff like that at that point.
Right.
I don't think.
Right.
But yeah, and like we literally just made an EQ.
Yeah. And that was just like holy crap. Like it's literally all an equalizer is just an array of resistors and capacitors. Yeah. And you can get more advanced, obviously, with like transistors and stuff, but for our course, that's all we did.
Yeah, exactly.
I think, what else was kind of stuck out to me as far as a project was the reverse engineering project from Engineering 1000, because we're still in the early years of college.
What did you guys do?
So I reverse engineered a Polaroid camera.
Oh, no way.
Yeah.
Was it like super complicated and like not straightforward at all? Like most things people
Yeah, it's definitely a lot different than you would think it is. Like it exposes the film, but the actual rolling pin that like spits out the picture is part of the reaction that gets everything cooking.
Oh, really?
Yeah. So like the rolling pin initiates, and I forget some of this stuff, but you can look it up. It initiates a lot of the actual color processing that actually happens to the photo. And people who say, shake it like a Polaroid, don't shake Polaroid photos, people.
I've heard that's not.
It blurs the colors, and it just you don't shake a Polaroid. I know it's in a song and it's really catchy, and so you think you shake it, but it might develop faster, but it's also going to be shittier quality. So just let it sit.
That's funny. Yeah, it is in that song. Shake it like a Polaroid.
Yeah, exactly. So don't shake it like a Polaroid.
That Outcast song. Yeah, and they actually like. I'm pretty sure. I saw like at the end of the music video or something, like somebody comes out and is like, "Don't shake your Polaroid pictures."
Oh, really?
Or something. Yeah,
that's the part everyone missed. Because every time I say, "Don't shake your Polaroid photos," everyone's like, "Well, it's in the song." I'm like, "Why is that the proof?"
Yeah, like, well, they didn't make the cameras, so what are you talking about? You know what else is in songs? A lot of horrible shit. So.
Yeah. There are other projects, but I'll save that for the later in college stuff.
Yeah. So, all right, just moving right along. Later into college, what was so for you because you're doing all this mechanical stuff? And I don't know. I guess we can consider biomechanics. I mean, it is more advanced because that class was hard as shit. But.
Dude, biomechanics. Yeah, that was our junior year too. So that was biomechanics for me was wow. Like this is really taking everything that we've learned from statics and material science and now applying it to human form. So, one of the test questions was like a skier is skiing down a mountain and twists their leg in this certain direction and their bone snaps.
Question. It was like hits a tree or something, right?
Yeah, and like what angle does their bone break at? Yeah. And you can calculate that. That's the cool part is that you can literally use math to calculate it if you know the forces and there's some assumptions going on.
Dude, and there was also like somebody gets hit by something and it's like, it was like a picture of the vertebrae and it was like, what happened to this guy's spinal column? How did they shift relative to each other based on this impact?
And you know what the craziest part is? That was the exam that ended me. That exam, for whatever reason, I like froze. And like I remember I did a bunch of like coordinate transformations that didn't need to happen. Mm-hmm. And I remember walking out of that exam and looking at everyone and being like, yo, I barely had enough time to finish that exam. And everyone was like, oh, I thought it was pretty simple. I was like, pretty simple.
Dude, because I was pissed after that test.
Yeah, dude, I remember Jeremy Hurd, him and his like hulking body that he had. Yeah. He like threw a chair at the end of that exam, dude. Everyone hated those exams because they always felt like you never had enough time.
That was one of those classes where like I remember walking out of that exam and I was like, I didn't think that exam was too crazy, but I just for whatever reason don't think I did well on it. Like,
right.
I was like, I think it was just like us like telling ourselves that class was hard when it wasn't as hard as we had made it out to be, and so we just kind of psyched ourselves out.
Yeah, I definitely psyched myself out for that exam for sure.
And I feel like after the first one, I feel like the first one was like, oh, what the fuck moment, and then after that we were just like, oh, this class is insanely hard. But it didn't really.
It didn't need to be. Yeah. It didn't need to be. And that's kind of what I learned. So by the time we got to the final for that class, I ended up going to a ton of office hours, which if you are wondering, go to office hours because it can be very helpful. I went to a ton of office hours and just worked with him and I fucking smoked the final and ended up getting a good grade in that class because I did well in the final.
So like what was the biggest difference between like lower level classes that you would take and like the intro classes like statics and stuff?
So I would say,
as opposed to the higher level.
Right. And I think a really good example is just the difference between statics and mechanics and materials. So statics introduces you to what are the stresses, what's the strain, what is all these different curves and all that. Like, we're trying to understand bodies in static, meaning in not moving. Because there is dynamics too, which I didn't take dynamics. Would have loved to, but I didn't have time to fit it in my schedule. Yeah. Dynamics is all about things in motion.
Some of the forces like isn't zero.
Yeah, because it can be. It's way more. I don't know if abstract's the right word, but there's more to consider for sure because you start thinking about time now.
Yeah, and you can't make assumptions. That's it, right. It would be more so like how things move over time.
Right, exactly. Now, so mechanics of materials now introduces what are the mechanical properties of this beam. So it's no longer just this is a box beam. It's now this is a aluminum 5083 beam. All right. So what are the properties of 5083? What's the, where's the yield point?
So it gets like more layered.
Right. More layered. We start maybe introducing things like factor of safety because, maybe it passes, but does it pass with this factor of safety, a factor of safety of 2 or something to try and be conservative? And it's funny because mechanics of materials ends up being, I think, the principal class of my current position job, and I can get more into that later. But that also related to kind of the biomechanics class. It's just biomechanics instead of being steel or something, it was bone.
Yeah.
And so, it's not, what do you call when it's like the same in all directions? Is that isotropic?
I can't remember, dude.
Yeah,
I don't know.
I'm like, see if you can Google that. I'm actually, I'm a little bit not sure. I forget. Yeah, I think it's isotropic, and anisotropic is when it's not the same in all directions.
I think you're right.
And like orthotropic also has another one. But the point being
same value measured in different directions.
Yeah. Okay. Cool. So now, what's cool is that the stuff, like I mentioned from, before, all that really happens is they teach you the basics and the grounding rules, and then they say, hey, we're going to add in some more variables. And that's pretty much what happens. Mm-hmm. I would say design and machine elements, which I took my senior year. What that did was say, hey, this is how you used to solve stuff. We're now going to solve it doing a way different approach that's technically faster if you learn how to do it. Now, it was a cool course.
So was that more like, was it all analysis too, or did you actually end up having to
It was just like mechanics and materials, except way more equation based, like a lot more derivative taking, a lot more like integral based stuff, but it was more simple. That's why it's like the simple stuff from Calc 1 and 2 were really applied in that class for sure.
With that, like I was going to say, like if there was something that you didn't think was important initially, but then turned out to be like super important later on in classes.
Yeah, that was pretty much it. I mean, another thing is how important computer programming was. I wish I had paid more attention to MATLAB, to be honest.
Yeah, it's pretty helpful.
Yeah, because we ended up using LabVIEW later on, and I understood LabVIEW really well for whatever reason. I think it's just like pictures and connecting wires for whatever reason that makes sense to me. And when we did the Kumavar project for bioinstrumentation, I made the like bicep flex, bicep perfect form machine. And I essentially took a flex sensor at the elbow and some EMGs and pretty much like did this thing where, if you bring a weight above the point of which you actually feel pressure. So if you are at a certain angle and then you stop getting pressure in your bicep, a red light would go off indicating that you had gone out of the rep range.
Okay.
So it was pretty
taking it out of tension.
Right. So the whole point of this device was to say, this is like a good range of motion that you should stay in, which I thought was pretty cool. But that used the basic principles from like our intro level EE courses that we took. And then also our biomechanics classes because of LabVIEW and all that.
That's right. I forgot you guys use LabVIEW for that.
Yeah. Which is like, I think other people didn't use LabVIEW, but I really liked having the display in LabVIEW. Like you could actually see the EMGs in real time.
So then that means that you guys, use the EMG, which means you guys use the NIDAC.
Yes, we did use the NIDAC.
Yeah, I was going to say, because I don't remember us having EMG sensors that were like microcontroller based that you could code like that. So it would have had to been.
Oh, actually, well, dude, they were the was it silver chloride?
Yeah, electrodes.
Yeah. There's the electrodes were just silver chloride. Do you mean like the advanced ones from like Delsys?
I'm just thinking, because so like the electrode is just like the actual like sensor itself, but then you need something to actually sense the data. Like you need an analog to digital converter.
Right.
You also need that's. National Instruments makes the NIDAC, which plugs like into the computer, which is an AD converter.
Yes, that's exactly what we use. For some reason, I thought you were talking about Delsys EMG sensors.
I was gonna say, like, there's a lot of those things are fucking awesome,
dude. Those things, first of all, wireless, awesome, and then their signal is so clean.
Yeah, that's so. There's a lot of like signal conditioning and processing that happens in the NIDAC. So to make something on your own using like an Arduino A to D, the signal would probably be ass.
Right.
If you wanted to get an EMG, unless you put some filters or whatever, but nobody knew what they were doing when we were making those. So I didn't think. But that's cool though. The EMGs, I didn't end up using the NIDAC because I didn't want to deal with LabVIEW. I was like the opposite. I was like, I want to just code. And
yeah, I remember that.
But that's cool though. I'm not going to ask really, I was going to say like senior design stuff because we kind of went over it.
Yeah, I mean, I can talk about my involvement.
Yeah, I was going to say, why not? Like a brief kind of like.
So last time we talked about how Adam had built with Cam our other buddy, which we got to have on the podcast.
Oh yeah, for sure.
But we built a navigational device for the visually impaired. And pretty much what that means is it's this almost like echolocation, you could say, for the people that are blind, visually impaired. And my job was, so basic overview of the design. You have like a belt strap, and on the belt strap, or like belt, what would you call that? Like a
it was a
belt buckle. Belt buckle.
Yeah.
So on the belt buckle that you would wear are like 3 ultrasonic transducers that send out really high energy pulses that you can't hear. It's in like the 40,000 hertz or something?
Yeah, it was like 42 kilohertz.
Yeah, it was really high. And so what happens is it bounces off of objects, it gets relayed back here, and then we can pinpoint 2 separate objects within that field. And then we relay that information to the person that's wearing it via a wearable grid of vibrating actuators.
Mm-hmm.
And so it's like this picture like spandex type material you strap over, and there's like a bunch of actuators all in a row, which are essentially these little things that just kind of vibrate almost like in your PS4 controller or your Xbox controller, whoever you are. And pretty much what would happen is if an object's on the left, it vibrates more on the left side. And then as the object moves, it'll kind of transition across the body. So the person wearing the device can essentially locate about where the object is. Now, my job was I need to make a housing unit for this circuit design that Adam and Cam had made. And so my job was pretty much using, I actually at the time used Simon's NX.
That's right.
Yeah, like NX Unigraphics, which is essentially a competitor to SolidWorks. And the only reason why I used that was because I had just taken a class for using Unigraphics or NX. And that's why I designed in it, because that was my wheelhouse back then. I had a whole class on it. And if you're a mechanical engineer or civil engineer, take a class with SolidWorks. SolidWorks is definitely more industry standard, so I almost wish that I had taken just a SolidWorks course.
What do you prefer? Like, which one did you think was more...
At the time, I thought...
I remember you liked it a lot.
I loved Unigraphics, man. I think one of the best parts about it was there was a help toolbar, and you could literally type in what you wanted to do. You could type in hole, right? If you just wanted to make a hole, and literally a hole like tool would come up and just be like hole generator. And you could click on it, click on your thing, type in how big you wanted the hole and where you wanted it, and boom, it would just make one.
Mm-hmm.
And in SolidWorks, I found it was very like, if you didn't know how to do something, you're going to YouTube.
Yeah.
Because that's it.
Annoying.
Yeah. And I found that to be annoying. I have used SolidWorks recently, and it is pretty intuitive now. I think they've updated it since we've been in college.
Yep.
But at the time, NX was my thing. And so I made, and actually this is pretty indicative of what happens in the real world too. Even Adam was kind of saying that, like on the last episode, that you work a lot with other engineers.
Mm-hmm.
So as an EE person, you'll work with a mechanical engineer, just like a mechanical engineer works with the EE guys. So every time they updated their design, I had to make changes to my 3D model that I made. And then what I would do is I would go to the 3D printing lab, and I would just print out demos all the time. I'd just rip out prototypes. And I got really good at 3D printing there too. And I was able to make a device or make a housing for this unit that housed both everything we needed, but also had the ability to open up to display all the guts of the design for senior demo day. Remember that? I made it so that, because normally I was like
with the door.
Yeah, I pretty much made a hinge that was just about the size of the actual hole, so I could tap it in and it would stay in without glue. And then I put like a little magnet on the end so that it would clamp together and just like, and it would, snap right on. But it looked really pretty for when we actually demoed the device on demo day. And so that was pretty much my job. And that took a lot of that was like so many iterations of that one design.
Yeah, it's kind of funny.
We went through iteration after iteration on like that design. And anytime you guys are like, oh yeah, we're using like a slightly different board now, I was like, oh shit, here we go. I gotta, the holes gotta match up and everything. So
yeah, it was cool. It was
cool.
And the mounting, like the whole like strap mounting of the actual thing itself.
Oh yeah, that's right. I think my shining moment was when, and I mean shining moment as like completely being sarcastic, was when we did our junior design, and we did it was the sudden infant death, the SIDS device, sudden infant death syndrome. Mm-hmm. Anyways, I had to come up with like a way that the baby would wear it, and I essentially came up with this giant it looked like a parachute, like something a parachute like or skydiver would wear. It was awful. It was a terrible design.
So funny. Baby jumpsuit.
Yeah, baby jumpsuit. I mean, it worked. It worked really well. Yeah. It allowed the device to be worn completely without having to do whatever. And my justification for that was because it was on a baby. If it was only a strap, I could see them kind of getting out of the strap. So I figured just this kind of jumpsuit apparatus would be better. It was just so funny. Dude, it was just so funny because I just remember we were presenting and like our device worked and it worked without being plugged in.
It was that one girl that was like, oh, but
what about if you want to, what was it? Swaddle.
Swaddle the baby or something?
I was like, swaddle? I was like, I don't know. Like,
well, yeah, I mean, we were talking about like preventing SIDS and it was like, oh, well, doesn't swaddling like increase the risk of SIDS or something like that? I was like, okay.
Yeah, I don't. But it was very strange. And then they ended up winning that competition because they found the the flex sensors.
Yeah, which like the only like all they did was show that the flex sensors worked and not that they actually put it into a design. It's like cool.
You found a sensor and you proved the sensor work.
It's like I bought this iPhone off the internet. Check it out. I can turn it on. Like what the fuck?
I know. I think the guy that was judging it just loved that idea of flex sensors.
It was just like, wow,
very special.
Yeah, it's very special. Wow. Yeah, but anyways, not salty or anything.
Yeah, we're not salty. But, all right.
But yeah, so I guess I was gonna say, like, how did your classes prep you for senior design work? I mean, I guess Siemens NX, right? Because you got to use it extensively.
I would say that class in particular was the class that prepped me the most for senior design, just because specifically I had to design a housing for an electronical device. And had I not taken that like 3D design course, I definitely would not have been prepared for senior design.
So there you go. That's a direct application there, which is kind of cool.
Yeah. Yeah. That was fun because I got to really use my imagination.
Yeah. Design work is just fun. You get to basically, I mean, you just come up with something. It's like, what can I figure out to like make this problem go away?
Yeah. Yeah, exactly.
But so grad school.
Oh, yeah.
Like, what was like the biggest difference between undergrad and grad for you? And did you think like 1 year was a good idea? How was the workload?
Right. So I think 1 year was one of the best decisions I ever made. Number one, I remember when I first was like saying like, yeah, I'm going to do a master's degree, but I'm only going to do it in a year, or I'm going to do the 1 year program because I want to get out and start working. One criticism I got was, well, are you doing a thesis? In our particular college at UConn, you don't do a thesis if you're doing a 1 year. You just do classwork. Mm-hmm. And someone had said, well, what's the point of doing a master's degree because you don't have a thesis? And the first thing someone's going to ask you at a job interview is, what was your thesis on?
What's the difference between a master's of engineering and a master's of science?
Right.
One of them has a thesis, one of them doesn't.
Oh, really?
Yeah.
Oh, shoot. So do we have a master's of science or a master's of engineering?
It's like weird. I don't know. Like, I'm pretty sure ours is a master's of engineering.
Oh, interesting.
It's like,
the master of engineering.
It's they're course based as opposed to research based.
Thesis based, right?
Yeah.
Now, the one thing that I can say with that is didn't really matter. Didn't matter to me.
Made zero difference.
Made zero difference.
Said that.
Yeah, I think. Well, the thing is that like I could see how like having a thesis is good because you're having to do the extra step. Mm-hmm. But I think the biggest advantage is less time in school, so less money spent.
Yeah.
And less like I got into work quicker, which I thought was the most important part. I wanted to get to working and getting a job and starting to pay off some of this debt that I've accrued at college, which amazingly I had accrued a lot, even though I had free tuition. So, fucking college is so goddamn expensive. And I was an RA I was an RA for an entire year. My whole junior year, I was an RA just so that I could help pay things back. And I still ended up with like I think I have like $60,000 in debt.
Oh my God, dude.
Isn't that crazy?
You were an RA.
Yeah. Oh, dude. Yeah. I should have a whole cast on our RA stories, man.
That's so funny.
That was just crazy stories, but that's a bit off track. I will say probably the most important class I ever took in my grad school year, and the difference between like grad school versus undergrad, I'll say that first. Difference between grad school and undergrad is the workload was crazy hard. And I think a lot of that was due to the fact that there were so many classes because we had to do it in a year.
Yeah. So we really had to stack. Well, they also like changed their requirements kind of in the middle. And like, oh, you guys need like 6 more credits than you have.
Right. Oh my God. I forgot about that. Yo,
I'm not going to graduate in a year unless I do research.
Yeah. That was the craziest shit ever. I worked in GP's lab specifically just so that I could just so that I could have something that wasn't another class.
Yep.
Because I couldn't imagine doing 7 grad classes in a semester.
Dude, it would have been ridiculous.
Yeah, it already was. It already was crazy doing 5.
Yeah.
I mean, most people, when they do their grad school, they're doing 2 or 3 classes at max 3 classes a semester. And we were doing 5 and 6.
Yeah, it was ridiculous.
Plus, we were doing 5 and 6 plus having a research. Like a research being in a lab.
Plus having I remember like I was working like 20 hours a week.
Yep.
Like that's such a good job. Like I had to go in and produce something.
Yep. And at GP's lab, I was pretty much just helping them set up their Instron testing machine so that for every one of their classes, they could just hit play and it would do everything for them. Mm-hmm. And so that ended up being helpful for her undergrad people, which I hope she still uses that program that I wrote for her. But because I just used the Instron testing machines at my
at the internship
at Medtronic. Yeah.
That was at Medtronic.
Yeah, Ovascience. I just did paperwork. I did some pipetting and stuff, but I realized I didn't like pipetting once I went there.
I had to do it monotonously for hours on end.
Yeah. But
robots to do that.
Yeah, exactly. Eventually, right? So I would say the most important class that came out of grad school was my finite element analysis course.
So do you think that had the biggest impact on
biggest impact on getting hired? It was the only reason I got hired. It was the only reason I got hired.
Really?
Yes,
that's
100%.
Crazy.
Because I had abacus experience and no one else on the candidacy did.
Oh, really?
Yeah.
No one.
Well, I think also it was APS, so I think I was like one of very few people that actually applied just because not a lot of people know about APS.
Yeah. Well, I mean, I feel like they get around at UConn. Like I was supposed to go
That's a good point.
to the career fair and like hand out whatever, like look at people's resumes and shit.
I think it was kind of like a perfect setup and like the stars just aligned because you had said, I just had an interview with APS. I think it went really great. Like you should check it out and see if they'll have anything. Because at this time it's kind of a funny story. I had thought I was going to get a job and I really thought I was going to get a job. They took me in for like 4 separate interviews, by the way. Like I interviewed with everyone in that goddamn company. And Thermatool. Huh.
Oh, Thermatool.
Yeah, I don't like them. So they took me to all these interviews and I did all this stuff and whatever, things seemed to be going good. And then I was like, all right, I can quit my serving job because I'm totally getting in with Thermatool. Oh my God,
dude, this is such a funny story.
And so it's my last day at my serving job and I'm driving there and I'm like, all right, I'm going to get an email for Thermatool any day now. And I got an email. I'm like, yes, here it is on my way to work on my day for my last day. And it's like, we regret to inform you that you are not selected. And I was like, what? But I mean, literally. And I show up and I didn't want to be like, I still wanted to leave because I wanted to have a really good last weekend at college.
Yeah.
So I didn't want to show up and be like, actually, can I keep my job? I was like, I'm just going to figure this out. So, but the funniest part is I've never lied like this ever in my life. But everyone was like, oh my God, you're going on, you're moving on. We're so proud of you for getting this job, And like, and the manager like wrote on like the whiteboard, like, congrats on the new job, Randy. And I was like, yeah, thank God I got this job. And like, the manager comes over and she's like, oh, I would have gotten you a cake. I guess I forgot. And I was like, yeah, don't worry. Like, no big deal. It's cool. And so I'm doing my last thing. Everyone's giving me hugs and congratulating me. And I'm like feeling like a piece of shit at this point, right? Because I'm like lying through my teeth.
Oh my God, so bad.
The manager comes in with a cake at the end of the night and it says, congrats on the job, Randy. And I'm like, I look at the cake and I'm like, oh, this is just
like one tear rolling down your face. You're just like cutting the cake.
Yeah. And it was a delicious cake, mind you. I don't know where she got that cake from, but it was really good.
Hey, did you want that fucking cake, you goddamn liar?
And she it was a great night though. I said bye to everyone. I was happy to leave though, because I was very done being in the service industry after working there for 5 years.
Funny.
And I get home and I just remember putting the cake on the table and Nick, our other roommate at the time, walks down, he looks at the cake, he looks at me, he's like, you didn't get hired. Because I had sent a text to all of you guys that, hey, I guess I didn't get hired, but well.
Yeah, I remember that, Nick.
Dude, Nick, he just looks at me like so matter of fact, like, Well, you didn't get hired. So what do you?
Yeah.
Oh
What
God.
do you mean?
Yeah. So, anyways, this is a roundabout way of saying at this time I was really struggling. I was like, damn, I need to try and find a job. And you were like, apply at APS. And I think they had just posted the job listing that day. And so because
you literally might have been like the first or second person to apply.
Yeah. And I think, and so what happened was when I went to go in for an interview, actually, do we want to, anything more about grad school before I keep going?
No, go for it. I mean, I feel like the highlight is FEA, right?
Yeah, it's really like ultimately FEA, which finite element analysis, ended up being the most important class because when I get to this job interview at APS, they pretty much just asked me a ton of finite element analysis questions. And it was the first thing they asked about. Now, one of the cool things was because I was also researching for GP and I had access to that Instron testing device, which essentially, if you don't know what this is like a machine and you picture it has like two grips on either end and you can put things in between them and squeeze it. And then the Instron machine either compresses it or pulls it apart. Mm-hmm. And that's what that thing does. They also have other advanced features that do torsion or rotational, but this one just went up and down. Mm-hmm. So what I did for my final project in my second semester of finite element analysis was I literally made a design in FEA. And it was this exact plastic component. I 3D printed like a plastic eye-shaped
I remember
device.
That actually.
Yeah, it was just it was like a 3D
I-beam.
printed I-beam. Mm-hmm. Yeah, and I just pulled it apart with the Instron testing machine, and I recreated the exact same thing in FEA to show that I could produce something in real life and also produce the same results in a finite element analysis. Yeah, so that gave me talking points when it came to time to do interviews because I knew that I could talk about that, but be like, yeah, I designed something in FEA and prove that it's the same in reality.
That's a cool project.
Yeah.
So
my teacher at the time was like, no one else did something like this. He's like, I like your project the best because you actually built something in real life and proved that it works in the simulation. Yeah. Everyone else just did they did ballistics theories and I think some other stuff. There's some people working for companies in there.
Did you see the what's it called? The difference between the simulated version and the real life version and compare the two? Or?
I ran into a lot of problems because I realized that in order for it to be exact, and I got it to be the exact same number. The only thing that was different is I printed out a bunch of I-beams. So there's some difference between each of them and how the 3D printer makes them. Mm-hmm. So some of them were plus or minus a certain error margin, mm-hmm. but it was consistent across the average. But what I realized was you had to be really, really specific to get the right answer. So, for example, I was just applying point loads at the corners of this I-beam. So if you picture the shape of an eye, in the center is the skinnier part of the capital I, right? So if you picture the corners of the top of the eye is where I was pushing up on. And so because I was just doing point loads, I was getting these really excessive stresses and deformations.
But technically it's grabbing the entirety of the top.
Technically it's grabbing a certain area, right? Yep. So it's technically a distributed load. Mm-hmm. And so I literally measured the grips of the Instron testing device and I did the exact same size applied across my simulation and I got the same answer.
Oh, that's nuts.
But I had to solve that problem. Yeah. I was like, why am I getting such concentrated loads? And it's because I wasn't simulating it properly.
Huh. See, that's cool. Because now next time you go to set it up, things to consider when you go to set up a simulation.
Right. Yeah. If you're going to simulate something and you want it to be accurate, you have to consider a lot more things than just basics. For sure.
So did you when you're with your APS interview, how did it go? Was it just a phone screen and then you met in person, or?
It was probably the smoothest set of I think the smoothest interview I ever had was for Medtronic, where he literally offered me the job on the interview. That was probably the smoothest interview I've ever had. APS went pretty smooth too, but it went, so half of not half, but a large part of our actual group that I'm now working for also works in DC. Mm-hmm. So I did have a lot of phone conferences. So I met with Chris, who is my boss, mm-hmm. and he was the main part of the interview because he was the guy that actually was in the group that worked there. That was just basic stuff. Can this guy talk? Does he know kind of what he's talking about? Did he actually learn stuff is he going to work with our group?
Mm-hmm.
And then they asked me the technical stuff about making analyses and how would I design this sort of FEA problem. And I felt very prepared for that based on the fact that I had just taken the class.
Yeah.
And then, so I interview with the engineers, I interview with Chris, I interview with Chick, our CEO.
Oh, no way.
Yep. And then, oddly enough, Chris is like, hey, let's have a second part of the interview. Let's go out to lunch. And I went, and this might happen to any person when they go on an interview. We went out to lunch and it was just casual conversations and just like, getting to know him. And then we went to the shop in Pawcatuck and he showed me around the shop a little bit. And then I met, what's his name? I forget his name, but I met someone else in the company that was like a big wig. And I got to talk with him too. And then by the end of it, I'm walking.
Did he work at the shop or?
No, I'm forgetting his name. He's like shorter, stockier, white hair. Oh gosh, I'm really forgetting his name right now. I mean, it's not really that important.
Yeah, that's fine.
I can tell you. I can ask after. I can ask Meredith after. I always forget his name for some reason. Anyway, so we finished that. I get out to the parking lot and Chris is just like, yeah, so like, we have really competitive pay. Like we have this and that, like, it'd be great. And so I was like, damn, I think I might've gotten this. So I felt really good leaving that interview. And then a few days later, they offered me a job.
Cool.
And that's just like, it just is one of those things where I just so happened to have what they were looking for.
Yeah. So like was the most important thing, the whole like FEA analysis project.
Like, I mean, getting the master's degree was the biggest deciding factor in getting a job, because had I not taken the FEA course, I might have missed out. Well, I definitely wouldn't have been working for ApS because they were looking for people with FEA experience.
Yeah.
So that definitely helped me out 100%.
That's awesome. That's good.
Yeah.
There you go.
I mean, that's why I have a younger cousin, Tanner, and he's a mechanical engineer. And I told him if his school has the option to do a 5th year for a master's degree, just do it. Do it now.
Dude, it's worth it. Honestly, it was worth it.
Yeah, because you don't have to go back now unless you want to get a PhD, which, that's up to you. But yeah, I personally just wanted to get the master's and get out.
Yeah, that's more of a money play. A PhD is not really a smart money play. That's if you're more just really interested in research and not so much like expecting you to get some substantial pay increase afterwards.
Yeah, you do, but it's like later on.
Yeah, and also there's just like a lot more of an expectation out of you as a worker.
Yes, a lot. There's a lot more of an expectation when you have a PhD.
But yeah, it's a lot of time and stress and effort to get a PhD, and the pay increase isn't going to be crazy. I mean, you're capable of doing a lot more, but yeah, you're not going to see like. If you spend 6 years doing a PhD and coming out and you're like, oh, I'm going to make so much more money now, you're probably going to be like, oh, what the fuck? This is not what I thought.
Right. Until later on. Later on in your career when you're like a big wig.
Makes it easier to like advance.
You know
what I mean?
Yeah. We'll have to get Cam on because he's... Actually, when's he finishing up his PhD? I keep saying we need to get Cam on. Cam, if you listen to the show... 2 years
from now, he'll be on.
2 years from now, he'll be done?
He's been in it for 3, right?
Yeah.
I'd give him like another 2.
Yeah, that's a good point because you just finished up classwork, right? That's all research stuff.
Yeah, so now I think it's just strict research.
Yeah.
But so like I guess on the job, save for what you like your little like lull period. We don't have to talk about that. That's kind of just a pitfall of a contracting company. But when you actually are busy, what kind of stuff? What does the day in the life of Randall look like?
So, in terms of my job. The most typical day, and I'll describe 2 because there was one that was really kind of unique. I don't say unique, but typical, I would say, and then one that I do specifically. So the one that was kind of cool that will probably be in a bunch of other jobs that I did for many months was, and I have to be careful how I phrase this. So a company wanted to see if they could design pipes differently. And I say pipes as in like, a pipe is also a square pipe, or it's a C channel, or it's an angled pipe. C channel is like this. It's like makes like a, it's like an L, but there's another side to it. And then there's an L bracket. And they wanted to see if they could get the same performance out of a C channel or an L bracket that the square tube got, but maybe just a little thicker than the square tube was. So we'll save on a lot of production value if we can just make an L or a C channel, but can it perform at the same level? And so I had to make this really big Excel sheet that was essentially a mechanics of material problem, but in Excel. and I allowed user input to show like what happens when you change different thicknesses on these different shapes. And so what would happen is at the end, they have a graph that they can look at that compares all the different designs, and they can kind of make a decision on their end. That's a really generic way of saying that, and I have to say it like that because I have to. But they, so that was a lot of fun because it was like I got to use mechanics and materials, and I got to use Excel for my method of programming, which if you're listening, Excel is actually extremely powerful and you can do a ton of stuff with it. And I definitely recommend getting good at it. And then a more typical day though is in the finite element analysis world. And this is pretty much going to be, for me, taking what's called a foundation. So we work on submarines. And a foundation is going to be like, let's say there's a fire hydrant and the fire hydrant is connected on the ship and it's on this little stool thing that holds it in, right? It holds the fire hydrant in. But we want to make sure that under some sort of loading, this fire hydrant just doesn't become detached from the foundation and like start bouncing around the ship. So my job is to take this foundation or the thing that secures said fire hydrant or whatever it is, and make sure that it passes all sorts of loading. And so what happens is I go into what I use is either FEMAP or Abacus, and I make a design, and it's like there's this whole process of reducing a 3-dimensional design to a 2-dimensional planar kind of like plates instead of like actual solid objects. And then you do what's called meshing. And so meshing is actually taking a item, like let's say this phone, and gridding it. So it's almost, if you know math, if anyone knows this, but Riemann sum. So it's essentially like, how accurate do you want to be? Because if your mesh is super non-dense, if it's not a dense mesh, you get less accurate, right? Because you're not getting all the bending.
It's like pixels, it's like resolution.
That's a great way to put it. So as opposed to film, which has infinite number of pixels, your quality of mesh is like is it going to be 1080p? Do we really need it to be that high fidelity? Do we need 4K? Does it need to be crazy high fidelity? Or can we go down to 720p? Doesn't matter. That's kind of the analogy. And then pretty much in the end, you spit out whether or not it actually works or not. And you can do things like analyze bolts. You can see the stresses in bolts and tell whether the bolts are going to fail. I mean, this is all stuff that kind of came from the advent of catastrophes, because we realized that we needed to figure out a way to test mechanical structures prior to actually building them.
Yeah, I mean, it makes a lot of sense because like you don't want to build something and, that's why we have things like factors of safety, like this can tolerate twice what we would expect it to see, just because you never know if something happens. You never know. We want
nature's crazy.
Yeah, like you know what I mean. There's some error margin associated with this part and the ship structure and whatever, and so like maybe the error margin like your tolerance goes down into the negative port. Maybe it's plus or minus 10%. It can withstand this force plus or minus 10%. Maybe it swings down 10% and it experiences some transient and we don't have a factor of safety.
Right.
And so now your part actually fails when you would have expected it not to.
Right, exactly.
Just to be conservative, something like that.
Yeah, and a big part of finite element analysis is looking at what's called mode shapes. So mode shapes are when you have resonance within a material with a certain frequency. So let's say there's a frequency like 50 hertz and your object happens to resonate with that 50 hertz, it gets a very strange deformation. And so this ability to see what the deformation looks like under certain mode shapes allows you to kind of predict, okay, well, how can we change this design? It's now failing a lot because this particular force is causing it to do all this wonky shit. All right, well, now we know we need to increase the plate thickness. So we didn't know that before when the mechanical engineers looked at it. But me as a structural engineer looked at their mechanical design and said, hey, we should probably increase the plate thickness because under these loading conditions, it probably won't actually do its job.
Cool.
As it were.
All right. Well, I guess closing statements here.
Yeah.
If you had some advice for somebody that was trying to go into ME, what would you
Well,
tell them?
first advice, if you are actually interested in doing design work and stuff, I actually don't know that I would go biomedical engineering. If you noticed, we didn't talk about biomedical engineering at all. And the reason being is that if you want to be a mechanical engineer for a biomedical engineering company, it's a lot easier to have all the mechanical engineering experience and then just have you teach you learn some of the physiology.
Yeah.
Of
Take some like applied electives in your like senior year or
right,
something.
Right. Or like literally like apply to a job as a mechanical engineer that's in a biomedical field, and they'll probably take you over a biomedical engineer. That's the crazy part.
Yeah, that's true.
It's so definitely do that, and pay attention to statics, mechanics, materials, Calc 1 and 2, and definitely don't be like me and negate MATLAB programming.
There you go. All good stuff. And yeah, that's the episode. Hope you took some tidbits out of there and put a glove on it.
I'm the one you